All right, today we're going to talk about Chapter 6, which is the chapter on sampling, and we're going to talk about what sampling is, some theories behind it, why we use it, and then the actual methods that we're going to use to develop our samples or to determine our samples. Today's class, we're going to cover the role of sampling in the research process. We're going to talk about the difference between probability and non-probability sampling. We'll talk about how to determine a sample size and what factors we need to consider. And then we will ultimately determine the steps to develop a sampling plan. And we'll go through a bunch of examples. So to just start you off, take a look at the cover of this book. Now, I personally would love to read this book. It's pink. It's got a pretty shiny ring on it. It's got cute font. It's got a quote from someone who wrote The Devil Wears Prada. I would take a look at this book and grab it off the shelves right away. But I'm guessing that there's a lot of you, particularly probably the boys, that would have no interest in looking at this book or reading this book any further. And if we take a look at this movie poster, just my gut feeling at looking at this movie poster is I have zero interest in watching this movie. I can look at the movie poster and I can make a determination about whether or not I want to see this movie or not. And I personally do not need to see this movie. So what I've done is made a snap judgment on the entire movie based on one little movie poster, based on one image. I've made a judgment about the entire movie. Same with the book. Based on one page, the cover, I've made a judgment about the entire book. This is actually where the idea of marketing started. It started in Wisconsin, and it started with studies of seeds and agriculture. This is where the study of marketing started. What they did was they sampled the land to determine what should be planted where. And then they sampled the seeds to determine which ones had the greatest potential growth and health. So they took little samples of the ground, they took samples of the seeds, and they tested them to see what would work best where. So some of the land samples resulted in uniform planting on the entire farm, meaning the entire farm was planted with the same seed. In other areas, though, they determined that a bunch of different seeds should be used in a bunch of different patterns of land. So the ground ended up looking like this, with different seeds used for different plots of the land. This is the idea of sampling. It's the process of selecting a small number of elements from a larger defined target group of elements, such that the information gathered from the small group will allow judgments to be made about the larger group. So anytime we select a number of elements and then use that information to make judgments on a larger population, on a larger group, we've done sampling. So when I made my first impression of that book or that movie, I was basing it on one small element. If we test drive a car, we're basing our judgment on the performance of the lifetime of a car on a quick 5-minute test drive. We base decisions on the assumption that the smaller sample is representative of the whole. And that is the fundamental idea of statistics, that we are making assumptions about the whole based on smaller groups, smaller representations. Here we go. All right, first one is the population. The population is an identifiable set of elements of interest to the researcher and pertinent to the information problem. So this is the entire set. So let's say if we're looking at the U.S., it would be all U.S. citizens. We might be considering the population to be all monkeys living in the Amazon. We might consider the population to be all cars registered in Kentucky. The population might be all books at the UK library. The population is the entire identifiable set of elements that are of interest to our research. The elements are those individual pieces. So if we're talking about monkeys in the Amazon, the elements would be the actual individual monkeys. The defined target population is the complete set of elements identified for investigation. So these are the ones that are relevant to our investigation and have been identified and defined by the research question as being eligible for our investigation. The sampling units are the target population elements available for selection during the sampling process. So some of those elements may not be available to us for research. So the sampling units are those target population elements which are available for selection during the sampling process. And the sampling frame is the actual list of all eligible sampling units. So this is the actual list. If we were talking about monkeys in the Amazon, how would we go about getting a list of all of the monkeys in the Amazon? This can be quite a challenge to come up with. It is the actual list of all of our sampling units. You may get this information if we're talking about, say, a retailer. They might get this information by collecting data on every single customer as they make a purchase. They gather every email address or every phone number, and they get a list of every single customer. It may be pulled from, if you're looking at people living in Lexington, you may pull it from a voter list. There's lots of different creative ways to get this information, and it again requires you to be quite creative sometimes. It can be very, very difficult to get lists. To get this sampling frame. And this is really hard. None of these are clear-cut, easy to find pieces of information. 95% of marketing research really is figuring out who the customers are, demographically, attitudes, behaviors, everything. Trying to figure out who these customers are and then how to get to them. So when we start pulling our samples, there's a couple of errors that you have seen before that we need to remember. There's sampling error, which is any type of bias that is attributable to mistakes in either drawing a sample or determining the sample size. Remember, sampling error is when the sample is a bad sample. We're now expanding that a little bit to include determining the wrong sample size or having a bad sample size. So anytime there is a difference between what the sample estimates and the actual from the population, there is a sampling error. A non-sampling error does not matter whether you are considering a sample or a population. So this could be measurement errors, poorly defined questions, response errors, etc. That non-sampling error is a bias that occurs regardless of whether the sample or census is used. And it could be, again, measurement error, response errors, coding errors. It did not have to do with pulling a bad sample. We're now going to move into the actual methods that we use in choosing a sample. And there's two broad categories here, probability and non-probability. So a probability sample is when each sampling unit has a known probability of being selected. It doesn't mean that they all have to have an equal probability, but they have a known probability. Non-probability sampling means that the probability is not known. So if we were to randomly select 5 students from UK's population, and let's say the population is 28,000 students, that would be a known probability. That would be probability sampling. We know the probability, we could calculate the probability of being randomly selected to be in that sample. However, if the researcher just decided that they needed to survey John, Tom, and Bob, well, that's non-probability. We didn't know the probability of those because the researcher just selected them based on their own judgment. The probability was not known. So non-probability sampling is when it's not known and the selection of those elements to be sampled are based on judgments of the researcher. And they may or may not be representative of the whole. All right, let's talk about the different, this is going to be a quick overview so you can see all the types together, and then we'll talk about each one of them individually. So probability sampling, we have simple random, we have systematic random, stratified random, and cluster. We'll go through each one of those. We also have non-probability, which means that the researcher has made judgments on who will be in their sample on their own. And these are called convenience, judgment, quota, and snowball. So we'll go through these, starting with the probability sampling. The first one is the simple random, and that is when everyone has an equal chance of being selected. It's a method of probability sampling in which every unit has an equal non-zero chance of being selected. That just, the non-zero chance means that everyone has a chance of being selected. An example of this would be a teacher just putting everybody's name in a hat and pulling out 10 of them. Systematic random sampling is when everyone is ordered, and then the sample is selected according to a position based on a skip interval. So what is a skip interval? Let's see. We start by obtaining a list of the units that contain an acceptable frame of the target population. So we get our list. We determine the number of units in the list and our desired sample size. So let's pretend we're doing UK students. So we get a list of all 28,000 UK students, and we decide we need a sample of 1,200. So we divide 2,800 by 1,200, and we determine our skip interval. We then start with a random point. We can start at the first one, that's fine. And we count. And every, say, whatever our skip interval is, let's say it's 20, every 20th person we circle, and they become a member of our sample. Then we count again. Once we reach 20, we circle them. Count again. Once we reach 20, we circle them. So we go through the skip interval and pull each person as we reach that skip interval number, and then we start over. We also have stratified random sampling, in which the population is divided into subgroups, and then a sample is selected from each subgroup. So if we were doing a study of UK students and we wanted to make sure that we had students from each of the colleges, we would get a list of each college's students and then randomly select from each of those lists. So rather than putting all 28,000 students together, we would get the list of engineering students and then randomly pick 20. Get the list of all business students, randomly pick 20. Get the list of all nursing students, randomly pick 20. That way we would be sure that we had students that were representative of each of the different colleges. And last, we have cluster sampling, which is a method of probability sampling where the units are selected in groups rather than individually. So let's say we were doing UK students. We could get each of the lists of the colleges, nursing students, engineering students, business students. Then in a bowl, we would put each of the names of the colleges. And we would draw out one of those colleges' names, like maybe we would draw out engineering, and then we would only survey engineering students. So a big key here is that may not be representative of all UK students, right? Because we're only looking at engineering students. So cluster is when we select our sample in a group rather than individual. Let's look, the slides are kind of silly here. This is back to that stratified. We determine the target population, and then we draw a random sample from each of those. And we're going to look at this using M&Ms. I normally do this in class in front of everyone, but I've drawn a picture. Hopefully it makes sense, and you can see it. We'll walk through it real quick. So for a simple random selection of M&Ms, we would put all of our M&Ms in a bowl, and that's supposed to be a little hand there reaching in and drawing out a red one. And the black circles on this page indicate our sample. So simple random would just mean reaching into a bowl of M&Ms and drawing out however many it is that you need. Let's say we need 5. So drawing out 5. We've already got 3. They've pulled out a red one, so now they're going to need to just randomly pick one more. Systematic would be lining up all the M&Ms, and there we have 21. And we need a sample size of 7. So we divide 21 by 7, and we get a skip interval of 3. So starting at the first one, we would count red, orange, green. Green is the third one, so we circle it. Yellow, red, green. Then we have another one. Green, yellow, red. Then we have another one. So every third M&M gets circled, and those end up being our sample. For strata, we divide them by, let's say, color. Red, orange, yellow, and green. And then we do that simple random selection process where we just reach into a bowl and randomly select one from each of the colors. This would be like randomly selecting students from each of the colleges. And cluster is when we cluster them all by color, and then in a bowl we randomly select one of those clusters to be chosen. So here we selected, that little hand selected the green M&M. So now we're going to sample all of the whole cluster of green M&Ms. Non-probability sampling methods. And we had 4 of these as well. A convenience sample relies upon convenience and access. So this is when the sample is just drawn at convenience by the researcher. So people that they just feel like, based on their at their convenience, the easiest to get to, that they would be a good sample. The judgment has a little bit more purpose behind it. It's when the sample is selected because the researcher believes they will meet the requirements of the study. So, for example, interviewing either salespeople or clients for the service performance of a dealership. The clients are probably better, but it's based on the judgments of the researcher that a certain group of people will meet the needs of the study. Quota is when participants are selected according to a particular quota for demographics. So let's say they need to hear from 50% men and 50% women. They may open up the survey to anyone, but once they reach and they know they're going to do 500 people. Once they reach 250 women, no more women are allowed to respond. Now only men are allowed to respond. So it increases the chances that future men will be selected because the women have been capped, essentially. And snowball sampling means that a set of respondents is chosen by the researcher, and then they actually help the researcher find more people. So if you refer someone to the study, that's considered snowball sampling. I use this quite a bit in my own research, where I will contact a salesperson and ask them to be a part of the study, and then I ask them to refer their close friends, their salespeople friends. And then I survey them, and then I ask them to refer me to someone else. And so it just kind of snowballs. You end up developing this list. So how are we going to set up our sample design? There are several factors we need to consider. We have some of the information on different types of samples, but what are we going to do? Our research objectives is most important. We need to answer the right questions. We need to choose a sample that will correctly and accurately answer our questions. Perhaps it's simple random. Perhaps it is snowball. Sometimes non-probability sampling is more important than probability sampling. So it really comes down to those research objectives. The degree of accuracy. Are we planning to make statistical inferences here? Or are we just getting some preliminary information? If we're going to make statistical inferences, we need to be very accurate. Resources, again, I've said this is typically time and money and people. So what kind of resources do we have? How much time do we have? The time frame of the research is the next one. Do we know the target population? What kind of knowledge do we have of the target population? Do we even know who they all are? Is it possible to get a list of them? If we can't get a list of them, then we can't really do probability sampling because we don't have a way to divide up the list or pull from a list. We would have to do non-probability, probably like a convenience sample, just get to who we can. What's the research scope? What are we trying to cover? Is it international? Is it just national? Is it local? That will make a big difference in the the broadness of our study and how easy it will be to reach people. And then if we're going to make statistical predictions from this, is it okay to use non-probability sampling, or should we stick with something more random? Lots of things to consider. And of course, you've all heard of sample size. We need to accurately determine how many people that we need to talk to, that we need to survey, that we need to sample in order to make those inferences. Here's some of the factors that affect that sample size. The first one is the variability of the population characteristic. So the greater the variability of the population, the greater the sample size we need. So if we have, for example, a really wide range of ages of drivers of Toyota Camrys, and we want to learn about drivers of Toyota Camrys, but they range from age 16 to 90, that's a really wide range. So because of all that variability, we need to sample a lot more people to make sure that we are pulling a sample that's representative of that entire group. The level of confidence desired in the estimate. We typically will go with 90 to 95% confidence, meaning on a very general level that we are 90 to 95% confident that our statistic generalizes to the population. We'll talk more about this later, but that's a very, very simplistic way of looking at it. And then the last one here is the degree of precision desired in estimating the population characteristic. So precision is the acceptable amount of error in the sample estimate. If we're doing a 7-point scale of how likely someone is to return to Panda Express in the Student Center, are we going to allow plus minus 1 on the scale? The more precise we want to be, the larger the sample size we need. So the more precise we want our findings to be, the larger the sample size we're going to need. Here are some of the formulas for determined sample sizes. These probably look a little scary. We actually will have a program calculate these for us, but I wanted you to see the formulas and see where this comes from. Statistics actually helps us determine the sample size. Unfortunately, in our work, sometimes we don't have this luxury. Sometimes due to money or time, we have to go with a sample size that's predetermined essentially. So some of these ad hoc reasons might be that we go with what we've done in the past, we go with a rule of thumb, we go with what's affordable, but we would like to use the accurate sample size when we can. So if you have a study of 500 or less, so the entire population is 500 people or less, okay, the entire population is 500 or less, it's better to go ahead and do an entire census and survey the entire population, because we would need 384 in order to have a 95% confidence. And plus or minus 5 sampling error points or standard error. So if you have a population of 500 or less, it's better to go ahead and survey the entire population. Business-to-business surveys are really, really difficult. 200 to 300 surveys is rare if we are surveying businesses rather than people. It's best to attempt to survey a whole population based on the company. The best policy overall is to just have a really strong understanding of who responded to your survey and know whether or not you can accurately interpret and make inferences from that data. But you have to have that strong understanding first. And just an important side note here, the population size ultimately does not influence the sample size. So we've said that if we have a population of 500 or less, then we want to go on and survey everybody. Other than that, the population size does not influence the sample size. So if you have a very small population, there's a formula that can be multiplied on the sample size to reduce it down. These formulas are for probability samples, remember. The ones that you're looking on the screen are for probability samples. Non-probability is based on some judgments or subjective. They are not based on these sample sizes. So how do we go about doing that? First, we define the target population, the group of people that we're going to be investigating, and get an understanding of what we're interested in. Then we select our data collection method. Are we going to do interviews or surveys or observations? We then identify the sampling frames needed. This is that list of all sampling units that we need, a way to reach them. So this could be a database, it could be a phone list, it could be a membership roster, it could be some register of all monkeys in Amazon, whatever the case may be. We then have to identify the appropriate sampling method. Is this going to be probability or non-probability? And we need to consider all of those 7 factors we talked about earlier, the objectives, the accuracy, the resources, the time frame, the knowledge, the scope, and the stats needed. We then calculate our sample size, considering both our time and money. We want to remember the variability of the population and the level of confidence. It's important to remember the sample size generated is less than what will be returned based on our response rates. So we'll probably need to increase our sample size just because we know that not everybody is going to return the survey. Then we need to, number 6, figure out how to contact that sample. We also need to write instructions for the surveys or training done for the interviewers or moderators. We need to create an entire plan for how to get them, how to select them, and how to reach them. And then we actually collect the data. Number 7, we execute the plan, we collect the data. We want to keep in mind consistency and control the whole time. All right, so that is the new information for Chapter 6. Let's make sure we covered all the highlights. We explained the role of sampling in the research process, what it is, why we use it, and that we are hopefully able to make inferences about our entire group based on our sample. We distinguish between probability and non-probability, where probability means everyone has a known probability of being selected. Non-probability, it's based on convenience and judgments, so there is no known probability there. We talked about the factors to consider when determining a sample size, things like the resources and the time frame, the scope. And then we talked about the steps in developing a sampling plan. And that was the slide we just covered in that entire order there. So that is it for Chapter 6. Thanks very much.